Alright ladies, here's an example now of how to fill in a Punnet square for an X-linked inherited condition. Okay, you'll see the Punnet square layout is essentially exactly the same as it would be for an autosomal condition, logically enough. So, the example I've got here for you is Duchenne muscular dystrophy. This is an X-linked recessive condition. We have a normal father, or a healthy father, and a carrier mother. So the first thing that we must do is decide what our notation is going to be. Let's choose the letter D to symbolize our particular allele. So we have two options. We have X capital D and X little d. Okay, so because it's an X-linked recessive condition, the capital D is going to be our normal allele, and therefore X little d is going to be our affected allele that codes for muscular dystrophy. If I can spell dystrophy correctly, that would be helpful. So we have a normal father and we have a carrier mother. Okay, so go ahead and put their phenotypes and in the top. So the female parent is a carrier. So you remember from the PowerPoint before, that means that she's with an X-linked recessive condition, she is going to be heterozygous. So she's going to have one copy of the normal and one copy of the affected allele. Okay, so in this case she's going to have X capital D and X little d. Hopefully you're saying it along with me. The male parent, on the other hand, is a normal, healthy person. Okay, so his genotype has to be X capital D, and because he's a male, he only has the one copy, so he's lucky in this case, Y. So the two options that can be passed on to children: the female parent can pass on either the X capital D or the X little d to her children. The male parent can pass on either the X capital D that he has or can pass on the Y. Okay, so we can go ahead now and put these into the top of our Punnet square. Like so. And then Punnet square is normal, so the first possible child will have an X capital D, X capital D genotype. Second possible child over here will get an X capital D from mum and a Y from dad. Our third possible offspring here will receive the X capital D from dad and the X little d from mum. And finally, this offspring here will receive the X little d from mum and the Y from dad. Please note that just like the convention is always to write the capital letter first in autosomal conditions, we do the same in sex-linked. So here, where this individual is X capital D, X little d, you would always write X capital D, X little d. If you wrote X little d, X capital D, it's stylistically incorrect, so please put the capital first. Similarly, with X and Y, we always place the X chromosome first. Okay, so it's always XY, please never write YX. So, you'll probably have picked up that the genotypic ratio for X-linked Punnet squares is a little bit more complex than it often is for autosomal ones. Okay, because you can see here that now we also have to account for different combinations of X and Ys, as well as the different combinations of alleles. So we'll go ahead and put here this first individual, who is going to be X capital D, X capital D. Okay, so we have one of those. And next we have one of X capital D, X little d. Okay, so when we do the genotypic ratio, typically we'll do the female offspring first, and then we'll list the male offspring. Okay, so we have one of the X capital D, one of the X capital D, X little d, and now we'll move over here. So we have one of the X capital D, Y individuals, and we have one of the X little d Y individuals in this particular example. So now when we come to writing down the phenotypic ratio, again, it's a little bit more complex. It's not just as simple as 3 brown, 1 blue when we're talking about brown eyes and blue eyes, for example, because we have to use the appropriate terms, as I showed you in the previous PowerPoint. So here, the first individual, you can probably work this out. Remember, this is an X-linked recessive disorder. So if you have X capital D, X capital D, this person will be a perfectly healthy female. The second individual we have, X capital D, X little d, will still be healthy, but because they're carrying one of the recessive alleles and can potentially pass this condition on to realistically 50% of their male children and 50% of their female children will be carriers as well, this person is referred to as a carrier female. Then this individual here, X capital D Y, this is obviously going to be our one healthy male. And finally, this individual here is our poor unfortunate soul who happens to be our affected male because he has the X little d Y and does not have one of the normal dominant alleles to protect him from the disorder. Okay, so just to recap, this healthy female here is completely healthy because she has 2 copies of the normal allele. This is the everyday person you'd expect to see, no issue in the world, and has no possibility of passing the condition on to her children. This second individual is a carrier female because she's heterozygous for the Duchenne muscular dystrophy allele. She has 1 copy of the normal allele, X capital D, and 1 copy of the recessive allele, X little d. 50% of her children will have this X little d passed on to them, at least by the odds, 50%, so that approximately 50% of her male children we'd expect to see showing Duchenne muscular dystrophy as a condition, and approximately 50% of her female children we'd expect to get this X capital D and be a carrier of the disease themselves. This healthy male here is perfectly healthy because he has X capital D and Y. Absolutely no chance that this male can pass on the condition in any way, shape or form to his children because he only has a copy of the perfectly normal allele. And finally, our affected male here, because he's X little d Y, will show the condition of Duchenne muscular dystrophy and unfortunately will suffer from this particular disease. Okay, so next task for you is this was the first of 4. Next task for you is to download the worksheet from the wiki. You'll see it under number 3 on the very front page of our class wiki, which the teacher will have linked to you already. You can download that in a Word document just like this and work through those Punnet squares. Following on from that, there's some textbook reading for you to do, and then after that there's also some questions in the textbook for you to complete. If you manage to complete everything today, first of all, good on you. And what you can do then is go back over your notes from the past couple of lessons, make sure you revise and understand the differences between autosomal inheritance and X-linked inheritance, and understand DNA replication and mitosis and meiosis, etc. I will try to be on email for the rest of this lesson. I can't guarantee that though. Feel free to shoot me an email question if one of your colleagues in the class can't answer the question for you, and so forth. Good luck!